Okay. Hi everyone. So I'm not sure if the disco next door is going to stop or not, or whether that's my soundtrack for my session. So I'm Mark Pritchard from Denodo. Yeah, just shout if you can't hear me at all. So in this session, I've got a very short presentation, which I'm going to describe how a logical data fabric powered by data virtualization helps enable democratization of data, and I'll attempt, fingers crossed, to illustrate the principles with a live demo. So hopefully that'll go well. So just to introduce Denodo, if you don't know who we are, we're a leading data management software vendor. Been around for quite a while now, since about 1999, and we're quite a global company, over 1,000 customers worldwide. And we have a single product, the Denodo platform, and the problem that it helps us to solve is the problem of data that's distributed. So distributed data, or data is distributed more and more so now than ever before. There's increasing adoption of cloud application services, data services in the cloud. There's still a need to maintain on-premise systems. So while this demand for data is ever increasing, the need for faster decision making, more complex requirements for decision making, growth in regulations, corporate governance, data security mean that the need for data integration is becoming more challenging. And traditionally, we approach data integration by point-to-point integrations, such as shown here on the slide, and they have their challenges, obviously. So what Data Virtualization and Denodo aims to do is that we provide a software platform that allows organizations to logically integrate, manage and deliver their data across their distributed landscape, which reduces the need for data replication. So the principle of the platform is to enable connections from any data source to any consumer. It provides a logical abstraction layer that decouples the physical sources from the consumers of the data. It presents the data in a logical model that can be easily discovered and queried without the need for the data replication. And it acts as a single point of access in which we can implement consistent security policies and governance. So how does that all relate to data democratization? So just if we take a brief definition of data democratization that I found here on the web by Bernard Marr. So data democratization means that everybody has access to the data. There's no gatekeepers that create bottlenecks in getting access to the data. And why that's important is that if we have availability of all data to everyone, then obviously that can help improve decision making. It helps empower users with self-service, helping reduce the dependence on IT, enabling consumers of the data to make decisions quicker, more informed. Democratizing the data means that typically data producers take more ownership and accountability of the data. So that helps improve quality and governance, and it also should aim to foster collaboration, enabling data owners to collaborate combination of data sets, empowering domain experts to contribute their unique insights into the data to help inform better decisions. So in order to enable data democratization, we obviously need a data architecture that's going to facilitate it, make it possible. And what we've seen is the rise of the data fabric as an architecture that provides this overlay across the different data processing platforms within the enterprise, that helps make the data discoverable, presents the data to the right users in a structure and a format that is easy to understand, easy to consume, and it aims to really automate the design, the integration, the deployment of those data objects and products, to help enable these quicker insights, and more importantly, sort of develop a trust in the data, irrespective of where the data resides in the underlying data processing platforms and technologies. So where data virtualization can help is it can really act as the delivery layer in a logical data fabric. So a data fabric that's powered by data virtualization can help onboard data quickly, abstracting the data, the complexity of the data sources where the data resides, and the different technologies in which it exists. It enables fast creation of semantic models and objects that can be easily discovered through self-service, through data catalogs. It acts as this single point of access in which you can apply consistent security policies across all the data platforms integrated by the data fabric. And it can support universal access to the data objects that are built within the fabric, exposing those to any consumer through common interfaces, common technologies, without the end user having to know the actual implementation of the data. So to illustrate that, I've got a brief demonstration. So the scenario is that a leading global wand manufacturer called iWander, which is an offshoot from Hogwarts, they find it difficult to get an understanding of their global sales across all their different channels. So each channel has their own systems. There's a heavy reliance on the Ministry of Magic, or IT, to help them put together the overall picture of their sales data. And the IT or the Ministry of Magic, while they're busy looking after Voldemort, they don't have the business expertise to create accurate data products, and it takes too long for them to get the data to the consumers. So iWander want to implement, or have implemented, a logical data fabric powered by data virtualization to support a data mesh approach, which they hope will improve the accuracy of the data across the different channels, improve decision making through self-service, and empower the channels to manage their own data products. Okay, so let me delve into the data fabric demo. So what I'm going to do is just log in as an administrator. In this case, Dumbledore, surprisingly enough. And when we come into the Denodo platform, we can go into the design studio, and this is the design interface that allows us to build out and manage the data fabric. So you can see, as an administrator, I've created a number of different virtual databases which act as autonomous virtual databases for the different domain owners. So I have for each channel a different virtual database, have a common domain which allows the administrator to create reusable objects which are governed, secured and maintained, and that can be shared across the domains. So within the data platform, it's very quick to onboard a new data source, so we can just select a particular wizard. Then when we select a wizard, which is very appropriate for Hogwarts, the wizards allow us to connect to the data sources and import the metadata from those data sources to create views on top of the actual data sources. So I can select particular objects, and then when I import those objects, that creates a view in the platform which allows me to basically query it using a common language, which for Denodo is SQL. So you can see I can query that object through SQL, and it doesn't matter in the fabric if we've created a view based on a database, a cloud application, an API, whatever. We can query it using standard interfaces, standard language like SQL. So also, as well as importing those sources, we can create more semantic views which add more information to the particular data objects. So if I just go to my integration layer, I have a folder full of logical dimensions, which are sort of certified objects which the administrators added some more descriptive information, maybe renamed the fields, applied tags for secure, which can indicate secure or sensitive data, and these can be reused by other domains, which we'll see shortly, in order to make them easier to understand and understand the security policies. So the tags also allow us in the data fabric to apply consistent security rules. So if I go to my global security policies, you can see I have an email masking policy which is applied to the data based on the tags. So the policies in this case says for particular roles, for anything that's tagged with email and sensitive tags, then I want to apply a masking rule. So that means that we can apply these data policies consistently in the logical layer, and then we'll see when they're reused by other domains, those policies are applied consistently whoever's querying the data. So having set up my sort of global common virtual database with these reusable artifacts, the domain users or engineers can then build on those to create their own artifacts. So if I log in as Harry Potter, so Harry is the store sales channel administrator. So if he goes into the design studio, he's able to see the same virtual data stores, but he has different access rights to each of the stores. So he has read access on the common domain. So he's able to access the common dimensions, for example. So if I open a customer dimension that we've got here, he can query that and use it in his own data products. So you'll see when I test query logged in as Harry, the data security policy against the email address is applied to mask the data. So again, with this different domain, we should get the consistent security rules. Then Harry can create his own products based on the reusable objects from the common domain. So in his store virtual database, we've got a few views that he's created already. So for instance, he's able to quickly create a view which consolidates sales across the different data sources in the common domain. So you can just drag in different views. We've got a date dimension coming from an Oracle table, a customer dimension again coming from Oracle. We've got a sales history fact table coming from a Presto database, and a campaign management reference API coming from a REST API. So he's able to quickly combine these. He can structure the data to apply different field names and descriptions to make, again, the semantic model more easily understood by other consumers, and he can apply functions to create calculated views, etc. As well as using the common artifacts, Harry can also create combined data products across different domains. So if I show you, for example, he has a channel sales history view, which currently has data products coming from sales and the catalog channels. You can easily add in objects coming from different domains. So here from the web channel domain, you can just drag in, you can drag in a similar view provided by the web sales domain. Then you can save that, and he can add that into his own virtual views. So then that gives him a view across all the different channels based on standardized data sets which are managed and governed by individual domain owners. Okay, so having created these logical objects in the different domains, so governed by the subject matter experts who know about the data, how do end users then get empowered to actually use those objects? So now if I log in to the platform as Hermione, so Hermione is a data scientist and a BI analyst. She needs access to data, and she's interested in customer information across all the different channels, and interested in the sort of sales picture across the various different channels. So Hermione is able to go to the data catalog to search and locate the semantic views that are built by the different domains very quickly. So if she opens the data catalog, she's presented with a nice search screen that enables her to, which is giving her recommendations. So based on machine learning and AI, the platform's recommending data sets to her that other data analysts or people with similar roles have been using that might be relevant to her to help sort of speed up search. Or she can add keyword search. So for example, she's interested in customers, and when we search for that, the platform searches all the metadata and provides a series of candidate views which might be relevant to her analysis. So in the catalogue, she's able to filter those based on, could be based on different domains. So maybe she's interested in customers which are probably managed by the common domain. She's interested based on tags. She can filter the data perhaps to views or data products which are report ready or certified. She can apply that tag to reduce the results, and she can also apply categories. So in the fabric you can link the different views to different categories. So here she's interested in customer 360, and hey presto, another magical reference. We've reduced the data objects down to something that's probably relevant, so we can go into the customer dimension. So Hermione here can see that this data set, hopefully maybe I'll make it a bit bigger for you, has been endorsed by Dumbledore. So he's saying that this is the de facto list of customers across all I Wonder channels. So that gives her some confidence that this customer list is something that's relevant for her. She can look at the schema, again see how the data is categorized by tags and the descriptions. She can also query the data just simply to get a view of the data set to see if it's relevant for her. So if I bring in the email address, for example, as well, because the catalogue's directly linked to the data fabric, it can preview the data directly from the source systems. And you see here that, again, the email address is consistently masked based on the policy in the fabric we've defined, no matter what interface she's using. So Hermione thinks, this customer data looks right, but I'm also interested in the channel sales, and where she can go to the relationships and see which other data sets are related to the customer dimension. And so you can see here there's an all channel sales object, which if she clicks on the interface, tells her that it's an aggregated view of sales across all the I Wonder channels. So again, this might be something she wants to look at. So she can click on the link, look at the metadata associated with that. Again, she can see that Harry Potter's actually endorsed this as the data product that it uses for consolidating the view of sales. She can again query the view, or if she has done already, she can collaborate by saving and sharing queries. So this is a query she ran before. And she can test that, and here we see the data that's coming back across all the channels through that view that have been created by the domain developers. You see these links here. These are relationships in the fabric that are defined that allow Hermione to traverse across different entities. So if she finds a record that's interesting, she can click on a link and see all the customer records, for example, that are linked to that particular data set. So again, this might be something that's really relevant for her. So having identified the data, now the principle is that Hermione should be able to use whatever tool she wants to actually do the analysis on the data, whether it's opening in a BI tool like Power BI, for example, which can link directly to the data set that she's found. So you can see here, this is the data coming from the virtual view, and that allows her in true Blue Peter style to create reports on top of that data as she would any other application. For data science work, she's able also to connect her notebook, her Zeppelin notebook, which is linked to single sign-on with the platform, and she can look at the channel sales analysis, writing queries as complex as she wants against that same data view to look at the data set. Then she also decides that she has a web application that she wants to develop, to access this data. So this data needs not only SQL access, but needs to be available via a REST API. And through the catalog, she's able to find the URI, you can just about see here, to access the data directly. So in this case, she tests it with her Postman client. She can call the REST API with the authentication as appropriate and get a JSON, in this case a JSON representation of the data. So this is an example of having easily discovered the data and found it. Then Hermione is able to present the data or consume the data using any sort of tool of choice using these standard interfaces. Okay. So having exhausted the Hogwarts analogies, I'll switch back to my presentation. So just to sum up, just the key takeaways. So hopefully, in that very brief, magical demonstration and short presentation, I've been able to sort of articulate how democratizing data is challenging because of the ever complex distribution of data and the need for faster, more complex decision making. Hopefully you can see in a very simplistic way how data virtualization can help provide a logical architecture, support the data fabric approach, and provide support for data mesh style implementations to access data and expose it quickly and easily and give ownership to the owners. And hopefully you should have seen the point that data virtualization enables you to centralize your sort of governance and security by providing this single point of access to the data. Before maybe I take a few questions, just a reminder that we've got a really nice booth with a roof on it, which is quite impressive, in the middle of the auditorium. So if you'd like to come along and see perhaps a more in-depth demo of the platform, talk in a bit more detail about how the platform works, I'd be more than happy to answer some questions. We have a colleague of mine that's also giving demos at the booth, and you can pick up a free copy of our book, Data Virtualization for Dummies. So with that, I think I have about 7 minutes if there's any questions. I'll try to don my... Any questions about data virtualization, Hogwarts or Harry Potter or anything else?
Hi Mark. Just a quick question about the typical use cases that you might see where people are using this logical approach rather than a physical move and copy.
That's a good question. There's ultimately, Denodo is an integration platform, so it supports lots of different use cases, different integration patterns. So we often see us used in situations in more operational use cases where we can provide data as a service, analytical approaches, so agile BI, supporting logical data lakes, logical data warehouses, single view of entity as well, so being able to quickly pull together data about a particular entity to give better insights across customers and their various transactions, and help supporting migrations. That's a big use case as well, so providing an abstraction layer across different legacy and new platforms, hiding the complexity and the movement of data between those to help de-risk migration. So there's a lot of areas that we see customers using data virtualization and the platform in to good effect.